With that being said, it is time to move on to the entities. I want to move to entities real quickly and just kind of discuss this normalization with an example. I don't think the way I explained it was all that great. So visualization is always better. So I'm going to make an entity.header file here. I'm going to make a class called entity. And here I'm going to include our globals. I'm going to pragma once just in case we use this multiple areas that end up in the final binary. Here, I'm going to create a constructor. I'm going to make a void update, a void fixed update, a void draw, and for now, we're going to do this real quick here, and I'm going to come back and do a little bit of rework. So vector2 position, size for another vector2, and let's see. So just kind of thinking here out loud. We need a position. We need a size of us. And we need a direction. That is a good thing to have. Oop, looks like some automatic thing there. And we need a speed as well. So we're going to go ahead, file, new, entity.cpp. I went a little fast here because we are going to end up redoing this quite a bit. This is just to showcase this example about normalization. So if we come over here, I'm going to include our entity header. We're going to call our entity class. And just to make sure that we make this public. And coming back over here. So entity fixed update, entity update, and entity draw. I'm going to use that alt click again. That way I can fill in void on all three. And here we are going to use some of Raylib's button press stuff. So I'm going to say if key pressed. So is the key pressed, and I'm going to say key W. And then I'm going to do S, A, and D. So up, down, left, and right here. And here I'm going to say direction dot X. Nope, this would be a dot Y is equal to a -1. And this is if we're going up. If we're going down, it's +1. If we're going to the left, it's -1. And if we're going to the right, it would be +1. If we're not doing anything, as in we are motionless, direction would be 0, 0. Now our guy needs a speed. I'm going to set our speed at 2. Seems kind of a fine speed for us. And I'm also going to set our position. So I'm going to say, hey, position, we're going to be 300, or yeah, you know what, 300 is fine for this example. And then size is going to be 20 by 20. We're going to come over here to our draw. I'm going to say, hey, I want to draw a rectangle. And this draw rectangle V is kind of nice because having a position, a size, and a color, I can just do position, size, and color like so. Now if I was to do the other draw rectangle, like so, notice it needs a int pos width and height. So I'd have to do like position.x, position.y, size.x, size.y. It's overall quicker to do it like this. And while we update, we could say, hey, our position in the x is going to increase and equal our speed times our direction, the x. And similarly here, our position in the y is going to increase and move by our direction in the y. This is fine. So if we file, save, and jump over to loop here, and I'm just going to say, hey, loop, we're going to make an entity called e. I'm going to jump over to our init function and say, hey, e, you're going to equal a new entity. We're going to make sure we include it here as well. So hash include entity header. That way this should populate correctly. And so what we did, we constructed our entity that runs this function here, sets these values. This is by assignment. There's a better way to construct as well. I believe it would be like that. And I think we'd use commas here. Not certain. Maybe I'd do like this for something like a vector. I think this is the preferred way. I'm reading a book currently, and it mentions that this is better on the compiler than inside here. But anyway, a little bit ahead of myself. We want to see if this works, right? That's the main thing. So in here, I'm going to call fixed update. In here, I want to call update. And right below here, I want to call draw. Now, one thing, I know this program is going to run really fast. I'm still going to showcase and just kind of checking here. Yeah, it had a warning, but looks like everything's still fine. Possibly not. Just kind of check here. Yeah, speed being initialized to 0, guys, would cause your guy not to move. And that's the other thing I did here. Is key pressed is different than is key down in Raylib. So is key down is the one that I'm looking for, like so. And clear, make, and go ahead and run our program. So notice we're super fast, like beyond fast. That is because we never set a frame, and instead of calculating delta time, you can actually initialize this using like a set frame limit in Raylib, which is pretty nice. So it's like frame should be frame something. Frame, not frame time. Set target FPS. Set frame limit is what that should be called in my opinion, but that's because I lost the battle. Anyway, make, run, and notice we're moving. Now, I wanted to showcase the normalization, right? This is why I sped run the entity. If I move to the right, if I move to the left, this is the same speed. Same with up and down. But what if I move diagonal? Notice it's faster. And this is because if we kind of look here, it actually makes a whole lot of sense. Inside of entity, we described its movement as its position increasing by both x and y. And in this case, when only x is running, the speed is being multiplied by either 1 or negative 1. And then here, the speed is either being multiplied by negative 1 or positive 1, right? So if we have a scenario where both of these are running at the same time, speed is changing both of these. And it's changing it at such a rate that it's slightly different. How can we fix that? Well, simply if we call our math function. So here inside of our header, notice how we call globals? Well, instead of calling globals here, we could call our math library. Because remember, math library does actually include globals. And that would allow us to maintain all that Raylib stuff, our screen width and height stuff, and be able to call normalize. Now we know that this takes in one vector. In this case, our vector is direction. And we know we want direction to be that. So now if we save, we compile, and we run our program, it looks like something was not there. That is because it's undefined. What do I mean by that? Well, we never set direction until it ran fixed update. So let's just try it like that for a moment. Come back here, we'll compile, we'll run. That seems a little strange. Ah, I think I see why. So, notice, big mistake. Divide by 0. What happens, guys? Math happens. And I included this on accident. This was me making a mistake. But it's a good thing to see, right? Because if you divide by 0, this is going to be undefined. Your guy's going to be kind of funky somewhere. So you could say, hey, if length is equal to 0, and what I'm going to do here too, so I'm going to say vector 2 new vec is equal to 0, 0. And if length is not equal to 0, we're going to go ahead and say, hey, return a vector. It's going to be this. Otherwise, we're going to return new vec. So 0, 0. If length is, equal to 0, it'll do this. If we save, come back, compile. In this case, I'm going to decompile, compile, run. Now we have our guy. And notice if we move left and diagonal, it's at the same speed now. And just to really make that apparent, if we comment that out, recompile, and run again, you can tell it's much faster going diagonal than if we were to normalize. And that's how you get movement to be the same. Like I said, this is going to be a little bit more in depth than just, hey, we're making Pong, right? Again, I want to create a system for you guys, a system of thinking of maybe we're not making Pong. Maybe we have to make something else. So might as well have these pre-written systems that help us accomplish those goals.